Okay, so I did a few things off camera because I wanted to just kind of take my time and ploddingly decide how I wanted to save the state for each of these pieces with the tools we currently have. The tools being jQuery and JavaScript. Well, I guess it's probably obvious that I'd save this through JavaScript somehow because that is the language that we are using. So what I did is, with JavaScript, we now have access to classes. So you can see that classes are a template for creating objects. They encapsulate data with code to work on that data. They're built on prototypes, but also have some syntax and semantics that are not shared with ES5 class-alike semantics. So in other words, we have access to some capabilities we would have in traditional object-oriented languages, like constructors and inheritance, which I am indeed using. So you'll see that I have this piece class with a constructor and then 3 methods, right? And then I have classes for each of my actual each of the actual pieces that inherit, or in this case, extend the piece class. So each of these have their own isLegalMove function because obviously each piece has its own logic to dictate that determines what's a legal move. And their constructors call the parent constructor but pass in a different type property. And by default, I'm saying that when I'm creating a new piece, it's by default going to be white. I have to change it and say that it's a dark square piece or a black piece, right? So then what I'm doing is my functions for actually adding those pieces now are creating a new instance of the class of each of these classes. So I'm creating a new pawn, and then here I'm creating a new pawn, and this false is just saying that, hey, it's actually a black pawn. And what this is giving me, well, I guess the other thing that I'm doing is, let's look at this add piece function. So here, what I'm doing is I'm actually, so this piece.type is going to be pawn, rook, bishop, knight, king, queen. And this is going to grab our template piece, clone it, give it a unique ID that is a combination of the square that it's on, its starting position square, and the kind of piece it is. Give it a class, which is going to be either text black or text white, and then we're going to add it to its starting position. But the other thing that I'm doing is this piece class, or really this instance of that piece class, I'm giving it some additional properties like the selector, which is the actual jQuery selector. I'm keeping track of its starting position. And then I might end up changing this. I'm not hard set on this. But what I'm doing here is I'm using jQuery's data method to actually save this class data, to couple it to the actual DOM element, or I guess the jQuery version of that DOM element, just for easy access. And then I'm also, don't worry about this too much. For whatever reason, when I was adding this piece to this data, the data object, I was losing notion of the class that I was inheriting from. So what I mean by that is instances of these classes, so objects that I make based off like the piece or the pawn, they save methods from that class that they're inheriting from, that they're based on. They save that in the prototype of this object, and I was losing that prototype as soon as I called, or as soon as I was saving it to the data of each DOM element. So I wouldn't worry too much about that. And then I also have an array where I'm storing each of these objects as well. So for example, if I look at piece array, I have an array of 32 objects, which makes sense because we have 32 pieces. And let's look at one of them. So you can see that this is a pawn. Starting position is A2, so this is the this object represents the data that we have for this specific piece. And I have a selector for it that I'm saving, which is just the jQuery selector. And then if I open up this is what I was talking about with the prototype chain. We have the prototype for the pawn class that we, so we have the prototype for this specific piece. So isLegalMove, if we look at this function, well, I guess we can't see it, but this isLegalMove function should be this function from the pawn class. But then if I crack open this prototype, these are all of the functions from the piece class. So it's all saved somewhere in the prototype chain. But for example, if I were to call, let's do piece array, and let's grab the first element, which is that A2 pawn, or the A pawn, and I call isLegalMove, pawn isLegalMove. So then let's call, like, I don't know, 16 isLegalMove. You can see that I have different functions for each of these pieces. One potential problem we have is there's some redundancies. I mean, we're making multiple instances of these objects. For example, the first object in this piece array is not the same as the object that's being saved in the jQuery.data for this piece. So I can prove that by, let's do a2.data. You see that this gives me an object. Is it giving me an empty object? It shouldn't be. Because when I call add piece, I should be saving. Oh, hold on. I'm looking at the actual square. I'm not looking at the pawn. A2-pawn. Okay, this is an object. So if I were to say, let's look at my piece array 0 dot type equals foo. If our jQuery data object was referencing this object that I just changed, I would expect this data object to have a type of foo now. Whereas if I look at the piece array, you can see it is different. So there's some redundancies, and I'll probably go in and clean that up. But those are, for the most part, the changes that I did off camera. So the next big thing is to take a sip of coffee. And then to add the logic, well, I want to bite this off in chunks, really, because I'll be drinking from a garden hose if I try and tackle everything at once. So I think what I want to do is when I click on a pawn, what time are we at? 10 minutes, okay. When I click on a pawn, I want to see circles appear that have each of my pawn's legal move, or all the legal moves for that piece, right? So I guess first of all, why is this board not taking up the full width? Oh, it's because I'm explicitly setting the width and height of each of these squares. That would be why. So what if I change this to, I don't know, 100? Well, then we've got really big board and tiny pieces. The reason I wanted to do this is because I want to take some notes. For now, I'll just zoom in. That's fine. So I'm going to zoom in, take a screenshot. I want the whole board. That's fine. Copy it. Zoom back out. Why couldn't you copy it? Why not? Can I take a screenshot this way with green shot? There we go. Okay. I want to add some handwritten notes here to kind of outline my idea for how we can start building a framework that we're going to use to drive our legal move logic for each piece. So what do I want to happen first? Or I guess what should the behavior be that we're trying to capture? So if I click on a pawn, so I click on my E pawn, I want to see in each of these grids little circles appear that show that pawn's legal move, right? So one way of doing that is I thought it would be useful to have some sort of logic that tells us the direction, the legal directions that each of these pieces can move. So scroll up. So I thought it'd be useful. So we've got the context of our piece, and really all of the legal directions any piece can move can be broken down into 8 directions, right? And I just want to save these, just going clockwise, starting from the very top. 3, 4, 5, 6, 7. Okay? So for a pawn, what are the potential directions this pawn can move in? Well, it can move in 7, 0, and 1. Those are the possible directions this pawn can move. It can move forward, obviously, and it can also move diagonally, only on these 2 diagonals, when it's capturing a piece. So, I gotta turn off the touch options for this tablet. Is there a way to just disable it completely? Okay. I forgot there's an actual toggle on the side of my Intuos tablet to disable touch. So this is a pawn. I guess this system doesn't really work for knights though, does it? Because knights can move. They move in an L shape. So they move 2 squares on one axis and then 1 square on another, right? So this notion of direction doesn't really apply to all the pieces, because what would I say for the knight? It's not moving, you know, how would I programmatically define the ability for this knight to move here? That's not a 7. 7, if it was moving in the direction 7, that would be on this diagonal. That's a great diagonal. Well, I'm proud of myself for that. And that's not true. So we might have to do some special logic for the knights. Every other piece, though, that logic applies, right? Bishops can move 7, 1, 5, 3, or I guess 1, 3, 5, 7. We should really actually have that going clockwise. Pawns can go 0, 1, 7. And then bishops are just diagonals. And then rooks are 0, 2, 4, 6. So what I'm thinking is, when we're actually going through and trying to decide what squares are legal moves, we can, there's a few things that we can do. We can loop through each of these squares on the board and call some function for our piece and say, is this a valid square for our piece? If it is, then save it to some list. Otherwise, do nothing with it. That's obviously very inefficient, because every time we're trying to move a piece, we're running that evaluation logic 64 times. Well, I guess at least 63, because we probably wouldn't have to run it for the square the piece is currently on. But in any event, that's pretty inefficient. So I think what we could do is, we know, like, okay, if the type that we selected is a pawn, let's get all of the squares that they could ever, that they could possibly go to, that there is a scenario where they could go to that square, right? So at the very beginning, you could say that this pawn could move to any of these 4 squares, or any of these 3 squares. Obviously, the pawn can only move to these diagonal squares. So this square, I guess D3, and then F3. It could only move to those squares if there's an enemy piece there, right? But we could at least say, hey, here are all of the conceivable squares this piece could move to, and then for each of those squares, then we could do our evaluation logic, which is far more efficient than having to run it for every single one of these squares, right? So for example, if we had a rook, let's say that we've got a rook here. That's a rook. What are the possible squares it can move to? It can move to any of these squares, any of these ones, any of these ones, any of these ones. So that's how we, like, the first pass we do is get a list of all of those squares, and then call some evaluation logic for each of those squares to see if our rook could conceivably move there. So for example, when we're running the evaluation logic on this square, D8, part of that logic would be, Is there a piece in the way? In this case, the pawn, then yes, there is. So you can't conceivably go through that square. So we'd have a method to get possible squares. And then I think a method to get a list of the pieces that are between our attempted move, if there are any. Or I guess let's get the squares between. Get interim, I don't know. Interim squares. So for example, we've got a rook here on d5. This is d5. We're attempting to move our rook over here to h5. First, what we would do is call a method to get this list of possible squares it can move to. Is h5 in that list? Yes, it is. Okay, move on to the second part. If h5 isn't, there's no need to run any more logic. We know that it's not a valid square. We don't have to do anything else. Then we call get interim squares, which will get all the squares that are between d5 and my attempted h5. So e5, f5, g5. It'll give me an array of these three squares. And then we want to see, is there a piece in one of these three squares? Let's see. So we'll have like an is square occupied method that will run for each of these. And if there's any scenario where this returns true, then we don't do anything. We're done. The rook can't move there. The rook could not move to h5. That's a pawn. Yeah, great. The rook couldn't move to h5 if there's a pawn here, right? Regardless of the color of that pawn. There's no rule in chess where a piece, other than the knight, I guess, which has its own brand of logic. So right now I think I want to program this for every piece but the knight. I think that's going to be easier, right? Which I opened up by saying that I want to just do this for the pawn and bite this off in small pieces. But, hopefully the way that we do it, if we add the logic for the pawn like this, hopefully that will be compatible for every other piece. So how does this work, say, for diagonals? So let's say we've got a bishop. Get rid of this. How can I do this? How can I do this? Let's say we've got our dark squared bishop. Did it just make the image bigger? Sure did. So we've got a bishop right here on d4. How would this logic work for the bishop? So remember, we click our bishop the first time, we click on another square. So let's say I click on my bishop, and then I click on f6 here. Click on f6. What we would do is get a list of the possible squares And that method for our bishop might be slightly different than for the pawn, obviously, which would have I'd say that each of our different classes will have a different version of this get possible squares method. And that get possible squares method would spit back an array of all of these squares. Okay? Is F6 in that list? Sure is. And then we'd call get interim squares, which will have logic so we know that the direction we're moving will be 1. So using the logic of what's our attempted movement direction, and knowing two things. What is the direction we're moving? In this case, that's 1. What is the square we're trying to end up on? F6. Those two things alone should be enough for us to determine what squares are in between, which in this case would just be E5, right? Is that square occupied? No, it's not. So that alone should tell us if this is a valid move. So yes, we can move to F6. Now, obviously, I keep saying obviously, this isn't necessarily obvious. At least it isn't to me, even though I keep saying it's obvious. But there are extra rules. So, for example, we also need to see if moving this bishop would say put our king in check. Like if this bishop is pinned, like if our king is right here, and they've got a rook, black's got a rook here, I can't move the bishop anywhere, right? So we'd have to do that. We'd have to do that check as well to see if it's a valid move, and that introduces a whole slew of additional complexity. So don't have to tackle that now, but it's worth keeping in the back of my mind for sure. So that's probably a good stopping point for this one. I think we have an idea of how to actually approach this movement logic and how to break it up into small pieces. So in the next one, let's actually try and code this for a pawn and get it working for at least one piece.